So yeah, my test on Tuesday. Well, I'll make it a 2-day test, like a Tuesday, Wednesday test. Because I know Tuesday's a weird day and Wednesday's a mass day. Thursday's the only normal day that you guys are all on a field trip. Like everybody, except Sophia. We'll hang out, solve math problems, be so great. Sophia, what do you have all day? Like empty class, empty class, empty class all day? Well, you're gonna find out. It could be a really great day. You could get all of your stuff done. Number 7. Let's make sure I'm on the page. Did I finish this when I did it? I didn't finish it. So, should be fine. So I was doing it the last part of the last hour. So this e to the y plus sine of x is pretty cruel. However, just like anything, when you're, like if you have x to the 3rd times x to the 1st, that's x to the 3 plus 1. This is what we have. We have e to a sum. So you can separate this e to a sum into the product of e to each added. Right? Isn't that the term? Stuff you're adding. So dy dx equals the cosine of x times e to the y times e to the sine of x. Okay? So we're separating the variables, meaning all the y stuff comes to the left side. And all the x stuff goes to the right side. So we multiply both sides by dx to get dx on the right, and we have dy on the left. And this cosine of x, e to the sine of x, stays. And then we have this e, we divide by e to the y, which is e to the negative y. So I guess we're integrating e to the negative y and y. And we choose a u here. U is sine of x. Du is cosine of x dx. So we're integrating e to the u du. So you integrate e to the negative y and get e to the negative y. I'm going to write that as 1 over e to the y. Right? E to the negative y times negative 1. I guess divided by negative 1. Because when you integrate this, if we took the derivative, we multiply it by a constant in front of the variable, right? But we're integrating, so we divide by the constant in front of the variable. So we divide by negative 1, so it turns negative. So that's the left side. And on the right side, we have e to the u, so e to the sine of x plus c. That's not a c, that's an e. Okay? And we use the point 0, negative 1. So that's funny, because I have e to the y on the bottom, but e to the negative 1 just moves e to the top. So it looks like on the side, at the point 0, negative 1, looks like we have e or negative. So side stays. And the sign of 0, 0, e to the 0 is 1. So it looks like C is -1 minus E. Is that what I got yesterday? Thanks for now. Okay. So we take this is what we got after we integrated it and plug this in for C. So mess. We can change the signs right here to that negative. Flip both sides so we have e to the y. Oh, whoa. These things are crazy. My aim is off down here. Really. So 1 plus e plus minus e to the sine of x. Now, natural logarithm.
Wait, what happened to the e to the negative y? We can't get rid of that.
Is that okay?
I think so. I don't know.
So I change all the signs, and then I flip both sides. Thank you. Right about that flippage. Now the natural. Let's just check it out. It's the point 0, 1. How is that possible? Should be a negative 1. Okay. Sine of 0 is 0, e to the 0 is 1, 1 minus 1 is 0. So I have 1 over e, which is e to the negative 1. The natural log of e to the negative 1 is negative 1. Not 1. Should I have a plus or minus someplace? If we integrated it and got the natural log, we would use the absolute value, which is plus or minus.
Oh, Mr. Bush, in the problem, it says 0, -1, not 1.
Yay! Oh, I love you. What was I wrong before when I said? Oh no, 0 and -1. Yay! Thank you. Yes, exactly. Like I was saying, this is correct. Okay, you good? And fun. definitely fun. Any other questions from the board? Oh, that's not right.
Can we do 50?
What is that one? Oh, yeah. 50. Hmm. Wow, interesting. Okay, so let's write this equation. What was the half-life? It's like natural log of, is it natural log of 2 over k? Is that really what it is? Thanks for knowing. Time equals 0. We have 100%. And time equals 199. We have 1%. Right? 0.01. That should be enough to find k. Point 0.01 equals 1 times e to the k is 199. Natural log of 0.01 equals 199k. K is this weird number. It's going to be negative, right? And I know the equation for half-life uses a negative k here, so our k ends up being positive. That's the only reason why. But we get k to be this number. So half-life is naturally 2 divided by 1. Is that a thing? It is a thing, I spend time thinking about it. Like the natural log of a quotient, natural log divided by natural log. No, it's a natural log of a quotient. No, it's just, you get a number?
30. Well, -30.
30? See? Fun. I'm checking it because it's a me problem. Look at that. Yeah. Like how rounded to the nearest half hour? Like it doesn't look like 30 to me. It looks like we give 29.9525, right? Because it's math class, not science class. Anyway, we'll appease this multiple choice question. Any other questions? That was good, right? That was a fun problem. 8.1, you guys ready for our last chapter? 4 sections in this chapter, one little chapter 9 thing you need to know. Which may be something, do you guys know what L'Hopital's rule is? It's a way to take a limit. So, if you're taking the limit is x, which is 5 of the fraction x times 5 over x squared minus 25. The requirement for L'Hopital's rule is when you plug in 5, you need to get 0 over 0. Or infinity over infinity, and there's other option. If you get 0 over 0, and then show that, like if you show this 0 over 0, right, which is nothing, which is not a number, you can use L'Hopital's rule. Do you guys know what the answer to this is before I do L'Hopital's rule?
-5.
It's 10. Right, because you can factor this into x minus 5 and x plus 5. Cancel the x minus 5s, plug in 5, 5 plus 5 is 10, so it's 10. That's what we're going to get. Okay? Anyway, if you get this and show it on a free response question, when I plug in 0, I get 0 over 0. Or we'll plug in this number, I get 0 over 0. It allows you to take the derivative of the top. So this equals the limit as x approaches 5 for the derivative of this top, which is just 2x. And the derivative of the bottom is 1. Now when we employ, well, this is employing L'Hopital's rule, and then when we plug in a 5, we get 10. And that's really the answer. Okay. So we're rules, right? If you try to evaluate the limit and you get 0 over 0, that indeterminate form, you're allowed to employ L'Hopital's rule. You take the derivative of the top, leave that on the top, derivative of the bottom, leave that on the bottom, and then plug in your number. And if you get an answer, that's the answer. If you get like 0 over 50, that's a number, 0, and the answer is 0, right? But really often you get a number. If you get 0 over 0 again, then you take the derivative again, the top, and the derivative of the bottom, and then plug in the number that you're supposed to be plugging into. That's L'Hopital's rule. That's the last thing you learn. That's not today. We're not there. Chapter 8 is the last one. We only do 3 sections in 8. So we'll be done by Valentine's Day. Definite integrals. Applications of definite integrals. This says integral of net change, areas in the plane, volumes, lengths of curves. Well, lengths of curves is not what we're doing, because that's a BCA. What the heck is this for? Describe the motion. So time equals 0. What is the particle doing? What's the velocity time equals 0?
-8.
-8. Okay? So what's it doing?
It's going backwards.
Going in a negative direction at a speed of 8, right? Centimeters per second. And then time equals 1, what do you have?
-3.
No.
8 of 1.
8. I think it's 1. 1 1 minus 2. Yeah, negative 1.
Yeah.
Yeah, good. And that means what?
It's going.
Still in the negative direction, slower though, so it's kind of slowing down. And then time equals 3, what's that?
Eight and 1/2.
8.5. Now the speed's positive. I think it's just going to keep speeding up, right? So, it starts in the negative direction, slowing down, and then it stops and continues in the positive direction, right? That's describing motion. Suppose the initial position of the particle is 9. What is a particle's position at time equals 1, time equals 5? You guys know what to do? So this is a chapter where the name of the chapter is Applications of Integrals. Right? That's the name of the chapter. And we have to find the position of the particle. Like, do you know how to find the position of the particle? Like if I'm here and I walk at a pace of 3 feet per second, right? 3 feet per second. How far am I in like 3 seconds? Yeah, 9, right? 9. So if I graph that, if I have time here and I have velocity here, I guess if I graph that, 3 feet per second is a constant velocity, right? So if I go for 3 seconds and it's 3 feet per second, where's 9 on this graph?
So inside the box.
Yeah, it's right, exactly. It's this area. Like the way you find the displacement is you find the area under the velocity function. And how do you find the area under a curve? Yeah, you integrate it, right? That finds the area under the curve. So as long as I know what my position is to begin with, and I know my displacement, I can figure out what my position is. So if I said, I'm starting here at 0, what if I start at 3? And at 3 meters per second, or whatever, feet per second, I travel in a positive direction for 3 seconds. But I'm starting here at 3. Where do I end up?
Well, 9 more meters from where you are.
Yeah, so 3 and then 9 is 9, 10, 20, what is it?
12.
Yeah, I'm in position 12, right? So the way you find the position is the position is the initial position, and we can call that DST, so S of 0, the position in time equals 0, plus the integral from 0 to wherever 3 of my velocity function. Right? That's how to find your position. You need the initial position and then the displacement. So the way you find the displacement is you just integrate the velocity function. So here this question asks, what's the position at time equals 1 if the initial position is 9? What?
Oh, we have to write these equations before.
Well, we know the equation. We know that the velocity function is
It's t squared minus something.
is it t squared minus 1 over, or 8 over t plus 1? So, position of time equals 1.
9 plus
9 plus
the integral of t squared minus
0,
8.
right?
Oh yeah, 0.
To 1 of t squared minus 8. I'm going to change the way this looks. 8 times t plus 1 squared dt. Like we could choose a u to be the function that's inside of the other function t plus 1, but its derivative is just 1. It would be 1 dt, and there's the dt right there. So we can work with this t plus 1 because it's same variable plus a constant, just like it's a variable. So this is kind of like t squared, but it's t plus 1 squared. We could multiply it out and make it really bad, but we're just going to leave it as something squared. So the integral of this is t to the third over 3 minus 8 times
Wait, it's supposed to be
negative
negative
2,
2.
right? So positive 16. Add 1 to the power. Negative 1. Divide by the power. Okay, we're gonna stick with this. So it's 9 plus 1 plugged in, this is 1 third, plus, this is a over 2, right? So 4. 0 plugged in is 0, and 0 plugged in this is 8, right?
Yeah.
And 0 plugged in is 0 plus 1. So it looks like it's 5 1/3. That's a position. 16 thirds. Bunch of stuff. It just is maybe the only thing that's taught in this whole section. It's the way you find a position. Is you start with the original position and add the displacement. So the way you find the displacement is you integrate it. What about the total distance? Remember, it started in a negative direction and then moved to a positive direction. You guys remember how to find the total area under the curve? So on the last test, we had total area under the curve, right? And I gave you the example of the SOW, the function for whatever interval, right? From A to B. So this is how to find the total distance traveled. Total distance traveled. Okay. Displacement is, no, it's not F, it's V. This is displacement. displacement, total distance, I probably should use t's. And A to B. And position is the original position plus the displacement. Right, three really important topics. Total distance traveled, that's the value of velocity. Displacement, the velocity. And position is the original position plus the displacement. So 5, we do the same thing, but we go from 0 to 5. 9 plus 0 to 5, we're gonna be done with it. What's your expectation?
Total distance?
What is the particle's position at time when it's 5? Positive, negative, what do you think it'll be?
Positive. That's a lot.
Right or left of this?
Yes.
None of this.
Right.
Right of this, right? Because it keeps going positive direction. After like, I can't remember what number we were at when it changed. Calculating total distance traveled. Find the total distance traveled from example 1. How do you do that?
Is it 0 to 5?
Yeah, example 1. Doesn't say. Yeah, 0 to 5. And that's a calculator problem. We're done. There's just that one section where I had you do the total distance where you had to find it using 2 integrals. Now we're done with that. Except you still have a quiz and well, maybe just a test tube at this point. Right? Find the total distance. The first one was a straight line. You just had to find the area of the two triangles. Second one was a parabola. And you had to change the sign of the negative part and add this positive part. And from now on, total distance, integrate the absolute value. Right, and that's it. Did you get an answer? You got it? So this is +1.
Minus 1? Oh, it is plus 1.
Yeah, that. Any questions about it? Can you get this in your calculator and get a number? You have to be in range, you do not have to be in range.
42. 5, 6, 8.
It's squared, yes. 2/3?
No.
No?
No.
Sure. It's 0 to 5, not 1. So you get 42,
Yeah.
5868.
Mm-hmm.
You good?
I forgot to put the absolute value.
So you did we do it?
Mm-hmm.
Your fraction is not very good.
There we go.
Like it's 8 divided by. That's the only thing I see now. Good job. Yeah, I put it into Y1 to make it malleable. Good? Whoa, here we go, check it out. So this is the same problem, except we don't have like a velocity, nothing moving. We have a pump pumping water. Right, water is pumped into an underground tank at a constant rate of 8 gallons per minute. So after like 2 minutes, how much is added?
16 gallons.
Yeah. Water leaks out at a rate of the square root of T plus 1 gallons per minute. So this is a little different. Like we can find the area of the curve for a line 8 from 0 to 2, right? But this function is not changing every moment, right? Because it's a variable that varies. This 8 doesn't, right? It just stays the same. This thing varies. So to find the amount of water that leaks out, we have to integrate this curve. How many gallons of water leak out of the tank from time equals 0 to time equals 3? How do I find that out?
The integral from 0 to 3 of e plus 1 squared
Yeah.
plus 1.
And get an answer, right? Why don't you guys do this quick? Give me an answer. Yeah? What?
4 2/3.
Yeah. Now, really often on the AP exam, units is a point. So make sure, if it is a point, they do say using correct units, right? But units is a point very often. So there. B, how many gallons of water are in the tank at time equals 3? Now I want to warn you that there's 30 gallons of water in the tank at time equals 0. The total amount of water in the tank is what? Starts with, is what?
30 plus
30 plus the water that's added,
24.
function that'll find the total amount. And then we subtract what? 0 to t. And then this is where things get weird.
Plus one.
It's plus 1. So this variable on your integral can't match the variable in your integrand, right? So this is the equation that finds the total amount. It's the amount you start with, plus the amount that's added, plus the amount that's subtracted. You guys should know enough to get the homework done. You can tell that the things that I'm teaching is a little bit weird to calculus, now that we know enough calculus to do that, to the AP exam.